Our next speaker was named in 2001 by Time magazine one of the 100 most innovative people in the world for the 21st century. Forbes magazine hailed Greg Lynn one of the 10 most influential living architects. Greg's studio, Greg Lynn Form, is constantly redefining the boundaries of design across multiple fields. You can see his work in some of the most recognized design and architecture museums, including MoMA, the Canadian Center for Architecture, ICA Chicago, and the San Francisco Museum of Modern Art. Greg Lynn has been a fundamental part of redefining our approach to design using digital technology, in addition to pioneering fabrication and manufacture of complex, functional, and ergonomic forms using CNC, that's computer numerically controlled machinery. Please help me welcome Greg Lynn.
I really approach questions of vision and technology in terms of an ecology of ideas. And so I brought a range of things, focusing primarily on changes in vision for designers and for architects. And towards the end, I'll talk a little bit about some work I've been doing with the HoloLens team and Trimble using the HoloLens. But for me, the augmented reality part of the talk really plugs into a whole lot of other things that are happening right now that let you connect things up into an ecology that didn't exist before in terms of design and also construction. So maybe 20, 30 years ago, well, actually 30 years ago, I started using animation technology for design, and really the best we could do is what we've always done in architecture, which is frozen motion. And so the advent of tools that were actually developed by architects, but also getting more traction in Hollywood for simulating physics and simulating motion, those kinds of tools let us start to arrange components and build spaces which had dynamism that previously wouldn't have been available. So a change in vision from static-based architecture to an architecture which had a rhythm or a motion of components where every component was a different size and shape, was in a different orientation, and therefore as you would move through these spaces, you would get a different kind of energy from the buildings. In this case, Korean Presbyterian Church, New York. That was a major change. I think what's the same about that from an architectural perspective is the environment we were designing in, meaning the space of design, was primarily static. There was nothing, there was no vitality to it. What's happened in the last decade, really, for me, is that my eye is now getting a whole new realm of things to look at. So I think the first thing is being able to use aerial and land drones, which we've been doing for quite some time, totally changes your perspective of design. This is a project for across the street from LACMA, from Wayne Ratkovich. If you look on top of that SBE building, you'll see a few people from my office who are actually flying the drone. But from the very first instance of design, we were bringing in drone footage of the building to look at the view of the apartments in the city, the view they would get around Los Angeles, how the building would look on the skyline. The perspective that we were designing from was a totally different perspective than that static space of X, Y, and Z coordinates where you start to locate building components. Now my eye was aerial and mobile, and we were very easily able to sync that up with 3D tools. With the 3D drawing space we were drawing in. I think what's probably more exciting for me, and this is a little bit of a tangent in terms of a project, but actually very fundamental to the way that I've been designing, is that I've started to design in a space which is not an inert static space, but a space which has flow and force. So I've been using computational fluid dynamics now to begin to shape and design things from a perspective of action and movement and dynamics. And for me, if there's one thing I want to see through my HoloLens now, it's force. I mean, I want to be able to not augment figures in a space or characters in a space. I want to see light. I want to see stress on materials. I want to see heat. I want to see wind, water, all of the things which have been invisible to architects are suddenly now visible in a digital simulation environment. About 3 years ago, I designed a boat for myself and more or less adopted a naval architect who works in our office now half-time, Fred Karubla. And the two of us worked with Long Beach State University to do the first coupled aero and hydrodynamic simulation. So you can see in some of these stills that as the boat's moving through the water, you're seeing the pressure as it's moving through water, and you're also seeing the streamlines of how it's moving through air. And what was incredible is we were on it would take a cluster of 64 computers a week to run through one simulation for us. So on a weekly basis, we were changing the design based on what we were seeing and how it was behaving in this environment. And we would literally take geometry, drop it into this environment, and with no animation, no keyframing, it would just take off. Because nobody was ever driving it, it always ended catastrophically. But we learned, every time we were learning things about the dynamics of how this was working. And what is really amazing is that a lot of the decisions we were making about where to put buoyancy and how surfaces were going to move through water, how chines and elements like this were going to keep the boat from flipping over end for end, and we're also going to shed water as it would move, was verified in the performance. And I'll show you just a couple quick videos. Also, how air was detaching from the surfaces, which would create drag. This is a boat that goes a little over 30 miles an hour with just wind. And so at that speed, actually drag becomes an issue just like it would with an automobile. Also I would just say there's a lot of 3D printing on this. The most critical components of the boat were all 3D printed carbon components. There's almost no metal on the boat whatsoever. And it was all built from CNC manufactured molds. So, so what you were seeing in that simulation in terms of how the hulls are in the water, what kind of wake they're generating, but even more importantly, how the bows of the boat are handling water and handling buoyancy, was really a high level of fidelity between that dynamic simulation using computational fluid dynamics and the actual performance of the boat. Nearly no surprises. As a matter of fact, some of the concerns we had were verified in things in the real boat that we now have gone back and retested and remodified. But mostly the foils, which are those big orange things that lift the boat out of the water so it can fly. But anyway, the video footage and the simulation footage almost always matching, like 1-to-1, with a very high degree of fidelity. If I could now bring that together in a moment, especially with augmented reality, where I could start to see those forces happening in real space. And the boat also, by the way, is covered in sensors, both speed and stress and wind direction, and it has a computer on board. So if I could start to pull those things together in real time, which is what they're doing in the America's Cup boats, you get even more insight. So for me, the question of vision is really a much more lateral question of a whole broad range of changes in the way we see things. Talk a little bit about robotics. Because I was doing these things with fabrication, and I would say in architecture, the primary use of robotics has been in how we manufacture, only because the construction industry has been robotic for a very long time. So architects really just have been learning how to talk to machines that are making things, and so primarily we've looked at fabrication. I recently started to think about what parts of a building could you move, and how could you integrate robotics into structures. So a few years ago for the London Olympics, we were asked to propose a pavilion. Here we integrated just 3. We were thinking about KUKA Titan industrial arms, but 3 industrial arms that could move a lightweight shell and spin it. But I've started to think about how to integrate robotics into building scale structures. Being able to visualize the motion with solid elements that can collide with each other lets you simulate that. I don't really think so much is important about the architecture here for this context. I think it's more just about how it's kind of moved across disciplines and fields. So this is in a robotics lab at UCLA I've got, where we use these large-scale robots to move models and even rooms around. And in building one-off robots to study some of these elements and get in-house the people necessary to both do the mechanical engineering and the mechatronics, meaning to build the robots, as well as people to program the robots, I kind of accidentally started to move into a different space. The San Francisco Museum of Modern Art wanted to include this in an exhibition, and I said, well, instead of having it just move on a loop, we should let people download an app on their smartphone and be able to drive it. And so using TouchOSC, which is a kind of music mixing program, we built an interface where you could start to move the models interactively by just downloading an app when you walked in the gallery, and then uploading our screen on it, and then being able to move this thing and also run it through some presets. So the ability to build the machine, the robot, control the machine, and then interact with people in a social way in a space really started to spread out a little bit horizontally some of the expertise in a way that was pushing me a little bit. Around that same time, I met Jaron Waldman, who started a company called Curbside, and that immediately became relevant in terms of, let's say, like little buildings, but more important than little buildings in the way people move through cities and in terms of transportation. And it got me thinking a lot about where, and I would never say like where the future of things is, because I don't really believe that's the future of things. I would say opportunities in thinking about urban planning. So I don't think anything is going this way. I just think this is where I would want to make things go. And it's an opportunity to be taken advantage of. What Curbside does is they turn a shopping mall or a big box store into a fulfillment center. So instead of having a big fulfillment center sitting outside the city and then shipping everything, so you can order a tennis shoe and it'll get hurled to your front door somehow by a drone or a delivery person, what Curbside does is it'll tell you where those tennis shoes are in stores around you. You buy it, somebody then goes and pulls that inventory out of an existing store. So instead of pulling the inventory from a fulfillment center, it pulls it from all of the neighborhood stores that participate in Curbside. They consolidate that. You drive up to one of their pickup pods or a pickup pin, and with some technology that's very clever about not draining your phone, they'll know when you pull up and be there to meet you as you pull up. And here in Glendale, where this is a public street, we had to prove to the Transportation Authority that we were not impacting them with more traffic. And so I dialed up the attorneys I knew that would be able to do a little bit of legal work for urban planning. And before I even had contract proposals from them, the curbside employees had been filming on their smartphones all the transactions for a week. And we just loaded those up into a spreadsheet and showed that the average transaction was less than 17 seconds. So by the time you would pull up and pull out, it was a 17-second transaction usually. And the way they do that is they would know what cell towers you were near by calling you and hanging up. And then once you got close to a cell tower where your stuff was, they start to turn things on your phone. And they have a Bluetooth antenna that needs to be kind of high up in the air to be able to localize. For me, the key aspect of all of these technologies is localization and positioning. That if you want to have your tablet be able to do AR or mixed reality, what you really need is good localization. If you want to be able to use a service like this, what they really have is localization. They know where you are, how fast you're moving, what you're doing with a geographic specificity or spatial specificity even. So, you know, the last thing we're doing now is as we look at doing more than one of these in an installation, we want you to know which one to go to. So we can localize you down to even one of, say, 3 pickup pods. And so we've got an antenna now that'll follow your cell phone signal and change the background of your phone to match the color of the pin. So they know who you are, and you know which pod to go to. So this kind of transportation and urbanism world has become very interesting. I want to show you something else we've been doing, but before that, I thought it would be nice to show you what I've been doing with Trimble and with HoloLens, with Microsoft HoloLens. How do I bring some of that virtual stuff and lock it to a physical model to give us a sense of scale, proportion, form, and space? Microsoft HoloLens is a wearable computer that lets you see holograms mixed with reality. It actually changes the way you think about design. I live here in Venice, California. I teach at UCLA in the old Howard Hughes hangar. We were asked by the American Pavilion at the Venice Biennale of Architecture to be imaginative and show what's coming with architecture. And we were given a mile-long building in Detroit that's been abandoned for 50 years to use our imaginations on. I'd known about the Trimble Microsoft partnership on the HoloLens and was just itching to find the right project to do a pilot with it. So we built a model, but we used HoloLens to get us inside some of those spaces. I didn't know how big our site was compared to corporate headquarters or museums. With Trimble Connect, I can look up and grab different buildings to compare. We could just pull a model and duplicate it and see that it would take 12 Tate Moderns to fill the site. That brought it to life in terms of use. Microsoft HoloLens lets us get inside stuff earlier and experience it, and I can look up and see the volume that I'm in and start to make decisions about how to design it. Without a HoloLens, I would have been making those decisions 3-4 months from now. But with the HoloLens, I'm making those decisions at the moment of inception. In the redesign of the Packard plant, showing the dynamics is something that's very hard to do. HoloLens immediately solved that problem, and it explained why things were the way they were because they were meant for vehicles and people to move around. I think that gives you a little bit of a sense of how that technology works. Crazy interesting to see what the world of entertainment and gaming is doing with these technologies. But for me, what's the most impressive thing about the HoloLens is, again, its localization. That it's building, as you move, a dynamic 3D model of the environment you're in that has enough fidelity that I can set something on the floor and it actually sits on the floor. And if I walk out to the cafe and come back in, that device is going to recognize the room. It's going to recognize that position on the floor, and what I set there is still going to be there. For me, when I got the first HoloLens in my office about 8 months ago, what was incredible is we opened a bunch of files. I put the device down, I came in the next morning, I put the HoloLens on, and all the stuff that was sitting there was still sitting in the right place. So that ability to know and map an environment is incredible. So what you saw happening where I was dropping modifications onto a model, it's great to be able to see virtual things in the physical world, but what is amazing is that it is looking at that model and matching it to the 3D model that we've got and being able to bring those two things together. So this, for me, the AR aspect is really connected to the world of self-driving cars, to drones. It's really all about cameras that are building maps of the world, or LiDAR, or any of these things that are mapping space in a way that it's never been mapped before, and being able to blur and bring things into those spaces because of the fidelity of those maps. And so for me, what I think, in addition to being able to see new stuff, these devices are letting me now see the world in a way that is not a plan, or a section, or a site plan, or a map. It's a high fidelity 3D world seen by machines. I've gotten very interested in starting to design more and more for machines. I think actually I probably made an interior design decision for a machine for the first time. Like, I'll show you an example of it. But one of the things I'm doing with designing for machines is connected with designing for elite athletes. I'm collaborating with Nike doing these chairs, which we call the microclimate chairs. But what we're doing is we're designing temperature and moisture controlled environment in a very lightweight piece of furniture for elite athletes. You'll see these with the NBA next year. What we do is both modify an athlete during the state of play, but we're also pulling data off the athlete during the state of play. Pulling the data off is probably more, well, they're both very significant. So what we do is, the first one we molded actually on an athlete, but we found out we don't need to have such a tight fit between the chair and the athlete. The material is a material which I wouldn't really say we've invented, we applied for the first time. It's a carbon fiber which goes continuously from being rigid to soft. So where you see those patterns of tape, it's soft, kind of like a hammock. It holds its shape till you sit in it, and then it turns into a tensile surface. And embedded in that, we can put a bunch of Peltier chips, which you can control from hot to cold by changing the electrical current through them, as well as a series of temperature and moisture sensors. And also we weigh the athlete, so every time they sit in the chair, we know as a baseline if they're dehydrating based on losing weight. There's a bunch of heat sinks to dissipate the heat that we're pulling off the athlete. Although really, and we don't tell the athletes this, what we're doing is cooking them, because you want to keep them hot. So we blow air on their face, and we chill their spines, and we chill the back of their necks so they feel like they're being cooled, but actually we're raising their body temperature and we're heating up their legs and arms so they don't get stiff. The very first prototype we did is much more reclined. We don't have this kind of real estate on a basketball court. But you can see the thermal camera taking the video of the temperature of the chair. This is Alessandro Gentile. He's bigger than me, much fitter than me. He's about 6'6", 6'7", which is your average NBA athlete. So that's the size it was made for them. But so we're pulling information off of him. Even through the clothing, we can get a lot of temperature sensing. The perimeter of it is all a 3D printed air channel that blows air onto his face. And also even, you feel it on your arms and legs, but we want to get as much of the arms and legs encapsulated in there as we can. So it's really like a tiny little oven. And there's some of the thermal imaging of it. So, building a microclimate like this, which is intelligent and is pulling data and modifying data, it's funny, it's something I pitched to Well, three of the largest furniture manufacturers in the world, two of whom I have furniture in production with, they all said, we know we have to do this, but we don't want to, so come to us when our competitor's doing it. Whereas I just casually mentioned it to John Hoke from Nike, and he immediately said, we need this, we feel like we're 5 years behind, let's do this right away. I know exactly the sport we should do it for. So for me, it's this ecology of machine vision, whether it's stresses and forces and environment, whether it's people and their temperature and their body state, whether it's a 3D map of an environment and mapping how many people are in it and how they're moving and recording it. Being an architect is really now completely changed in terms of responsibilities and opportunities. So I really think it's now about not designing spaces for machines, but designing spaces for people and machines to work together, to move together, and to have a kind of intelligent fusion. And the obvious place where people and machines are working together the most are factories. This is some footage from that Packard plant, which was just a kind of hypothetical project done for the Venice Biennale. But our idea was to take this existing factory and think about what it would be today if you were to bring in a fulfillment center and a manufacturing center and a university all kind of onto the site, like Cedric Price did in the 1970s. And what we came up with was this idea, instead of a gantry, which is a crane that moves things through a factory, which is the old idea of a factory, to think about a kind of a little mini freeway for everything from the scale of a forklift or pallet jack, which is automated, down to small, lightweight point-of-use carts that might move around. So people and machines, the people would move on the first 3 floors, and machines would move, instead of in a gantry, in these kind of tubes. And I'll show you in the last couple of months how this has moved to a real project on Lake Como in northern Italy, which is also an old factory. And again, for this project, we shot everything with aerial drones. I mean, I went to the site, but frankly, I spent most of the time on the site looking over the shoulder of somebody with a tablet with an aerial drone. But so again, it was all shot with aerial drones. It was all, we were using the HoloLens. It was a fusion of all these things. In Lake Como, we're now doing something similar for a smaller scale renovation, where we're building a new engine plant and plugging into an existing assembly plant. And you can see we're building a plaza so people that are passionate about the brand can come to the Moto Guzzi factory and visit, but then instead of having the machines only moving through the factory, they get to get into this tube you see and get led by machines through a view of the factory and begin to enter into spaces where it'll be primarily machines doing the work. And that has led to a foray into vehicles, but really my role here is not so much designing the vehicle, which that is my role, that's my job, I have to design the vehicles, but really we're trying to design cities, and we're trying to design sidewalks, and we're trying to provoke a new kind of fusion between people and machines. And it came out a little bit from this. Like if you see these little balls around for the scale to the motorcycle, you know, we had an idea that the path that people should be led around, they should be led around by these little guides. And our idea was primarily to have something autonomous that would do that. What ended up coming out of this is something which is not autonomous at all, but something that's all about the partnership between people and machines or people and robots. A year ago, I co-founded a company with Jeffrey Schnapp and with Piaggio, and Piaggio are the people that they invented the Vespa, called Piaggio Fast Forward. And it's all based on what you call SLAM, or simultaneous localization and mapping. So that's how HoloLens works, is it has stereo cameras and it does on-the-fly SLAM, where it uses those stereo cameras to localize and map. So it builds a map and then it puts you in that map space and compares that against the world continuously as you move. So our idea is really that we're starting from people and what people might want in the city. So you see that person, Jared, is getting followed by our vehicle. And I don't call it a robot, it's a vehicle. What it does is it carries 40 pounds of stuff and it follows him in a very sophisticated way. It's building a 3D map of the world. If actually you could click on the one on the right as well, it doesn't automatically launch. But here what you see are two views of our offices. And I just thought this is a kind of a funny story that we expanded, so we got a second space, and somebody from the office called and said, well, look, Greg, we need to have carpet, and tell us what carpet to get. And I said, well, call Helen at Bolin and get some Bolin carpet. And so they then called about 3 days later, said, we have the swatches, and we have 3. Can you tell us which one to pick? And I said, I could really care less about the carpet in our factory. So I said, show it to the robots and see what the robots like. And I meant it a little bit as a joke, but it's a big deal. They actually need environments with a little bit of differentiation in order to localize. So I thought, well, let's help them out and let them pick a carpet they like. So on the left, you saw a carpet they didn't like, and on the right, you saw the carpet they loved. I frankly couldn't tell the difference between the two carpets. They both were just gray, but they picked up 10 times as much information off the one carpet as the other one. So we're starting to design. I mean, look, I designed the space so I knew we could drive the robots around. We picked desks which were high enough so they could drive under the desks. I made all kinds of decisions which weren't for the people that work for me there. I made decisions for the robots we were building. So I was already designing for machines, but I was actually even picking out finishes and doing interior design for machines. And I think this is the world we're in now. This isn't the future. This is what everybody should be thinking about. So the next round of Bolin carpet, you'll see a little icon that'll say robot approved. And I really think this is a big deal. I mean, for anybody with a HoloLens, they're going to want that carpet over another one because they're going to localize better in it. But it's the stuff you have to be thinking about. So to get back to the city, what Jeffrey and I really believe, and we were provoked in this because Piaggio, they're a consumer company. So they always want to know what their customers want. And because they invented the Vespa, they care about quality of life. They want their products to make people happier, more social. They want them to go drive to a square and have a coffee and meet other people. So when you say, when you go to Silicon Valley and you say, I've got a navigation technology, in seconds the discussion turns to, we can replace that person in 2 years, we can replace that person in 5 years, and we've got a plan to replace that person in 10 years. But everything is about, give us a job, and then let's figure out how a robot can do that job more efficiently. So we started with a very different attitude because of Piaggio, because they want customers and consumers, and they think in a consumer way, not in like a business-to-business way, which is not to say we're doing business-to-business development right now, not consumer business. But so what we thought about was, how do you do something like a scooter, something lightweight and granular, and how do you put this inside buildings as well as outside of buildings and on sidewalks and bike lanes and take advantage of that scale of movement. This is a video of Hanoi. You'll see motorcycles, scooters, bicycles, pedestrians, building materials on bikes. You know, every small scale, if you put each one of those people in a car, it's ridiculous. So self-driving cars, you know, good luck. I mean, great. Personally, if you just said from a qualitative standpoint, do I want to sit on a couch and order a burrito and have it fired through the window on my lap? No. I would rather go take a walk to the restaurant in my neighborhood. Do I want to call up a car and have a car that's empty, pull up and hop in the back seat of it? I've done that. It's weird, it's fun. It's not very social. I mean, and the one thing all of those things do, we learned, is they free up your hands. Like, self-driving cars are all about getting your hands free so you can be on a telephone. So we thought, how do we get people's hands free, but not put them in something as cumbersome as an automobile? So if you want to go, Nicholas Negroponte is the head of our advisory board, and Nicholas said he loves to cook, and so he buys fresh ingredients every day. He walks in his neighborhood to buy his dinner. But once or twice a week, he gets in his car and he drives to the corner because he's buying a case of wine or because he's buying a couple gallons of milk. And so we wanted to give the people that use a car to carry 40 pounds an alternative that would let them hop on their bike, get on their skateboard, or walk. So that's our vision of the city, that Toronto is going to look more like Hanoi. It's not going to be full of self-driving cars. It's going to have to be full of lightweight mobility because it's more efficient, much more efficient. So our idea of autonomy is autonomy for humans. So we want to extend your range. We want to give you an option. We want to get your hands free, and we want to be able to carry for you so you can make decisions to move more and actually be healthier and more engaged. Like walking or riding on a sidewalk or in a bike lane, you have a very different experience of the city than sitting in the back of a car with the windows up.
Because we come from Piaggio, we see cities in a different way than an automobile company. We think about people moving in a granular way.
Granular mobility is a concept that we have elaborated within Piaggio Fast Forward to call attention to those spaces that we navigate as pedestrians, as citizens of the 21st century city.
We thought, let's try to make a product which engages all those different cities and the way people move in all those cities.
Jita was designed to leverage the power of human navigators of urban spaces to make sense of them. We imagine it as a kind of Vespa for the 21st century.
Jita is thought to help the human, from a young kid at the school to an older one in a hospital, for instance. It's a total fusion of the two technology.
It's a land drone, it's a cargo bot, it's a Sherpa, and it's a smart device that learns the environments and maps them as it travels them with human guidance.
It moves as slowly and can maneuver the same as a human, and it can move as fast as a human can run, and everything in between. It can also comfortably carry about what a human can carry.
Jita has two main purposes. It is thought for goods transportations, for people transportations, and to mix them to help people.
And we see a future where city streets are not full of autonomous cars, but people walking, jogging, riding on lightweight devices like skateboards and bicycles.
We believe that the 21st century will be the century of robotic movability.
Okay, so here you see three of them following three people in a really small space. But I guess in kind of closing, for me, this is augmented reality for me. You know, this is literally exactly the same as a HoloLens. It's building an environment. It's making decisions about what that environment looks like, what the surfaces are that it can move on, what's an obstacle. It knows what a person is, so it can delete people out of a scene in terms of building the three-dimensional scene. The only thing that's different than that is it's not about putting that now on my eyes. This is a machine with vision, and so my job is we've got dog trainers and falconers and horse handlers all coming into the office and talking to us. We're trying to figure out when you go through a door, how do you hold a door for, sorry, the product's called a gita, which means short trip in Italian. So when you open a door, how does it go through a door? Does it follow behind you? When does it come next to you? When you have to program it, meaning sync up with it, it gets in front of you. Like we're trying to figure out what's the protocol spatially to interact with a robot in an environment. But for us, this is a world of augmented reality. I mean, it really is exactly the same technology as the vision technology. It's a different experience, like being with a robot, than looking at something superimposed on your field of view. But it's the same ecology. And by the way, as we're hiring engineers, we're competing with Hollywood and HoloLens. Like we have to pay the same salaries, we're looking for the same people, exactly the same job description that we hire, that somebody that's working on a 3D augmented experience for Hollywood is working with. So it's really part of that whole ecology, I guess, is what I would want to say. And for me, my perspective is really not the product design of this thing. It's about changing the way people live in cities and being a spokesman for the citizen and for the civic space. It's kind of hard to show that, but it's embodied in this object. It's why you don't ride on it. It's why it makes you move and hopefully, makes people walk more or ride more. And it goes 22 miles an hour is what we limit it at, but that's how fast Usain Bolt runs. So we made it go as fast as the fastest human, but it can also follow a bike because of that. But so I'm out of time, but so I just thought I would show you then a quick little view of what a city might look like that was filled with these things instead of automobiles. Okay, thanks very much.